Have you ever paused to think about the invisible chemical forces that are literally shaping our everyday world? I mean, from the tangy zest of the food we eat, right down to the slippery suds we use to wash our hands, there is this silent, fundamental chemistry happening right under our noses. Welcome to this explainer. Today, we're diving into one of the absolute most fascinating rivalries in all of science. We're talking about the clash between acids and bases, and exactly what happens when these two extremes finally collide.
Here's how we're going to break it down today. Section 1, Meet Acids and Bases. Section 2, A Tale of Opposites. Section 3, The Color-Changing Clues. And Section 4, The Ultimate Chemical Clash.
So, before we really get into the heavy science, think about this for a second. What do a super tart lemon and a plain old bar of soap actually have in common? Honestly, on the surface, absolutely nothing. But in the realm of chemistry, they perfectly represent the two opposing sides of a massive fundamental divide. They're kind of like the everyday ambassadors for our two chemical heavyweights.
Section 1, Meet Acids and Bases. Think of this whole thing like a map that splits right down the middle. On one side, we've got a distinct red pathway for our acids, and on the other, a blue pathway for our bases. Basically, they live in totally different worlds, playing by totally different rules, right up until they finally crash into each other at the very end. But to really get this, we have to understand how they start out. So let's kick things off with the acids.
Okay, so what exactly is an acid? Well, chemically speaking, acids are substances that donate H+ ions when they're in a solution. If you zoom all the way down to a molecular level, you can kind of think of them as these super generous donors playing a microscopic game of hot potato. Whenever they're mixed into a liquid, usually water, they are always looking to just give away a positively charged hydrogen ion. Just, here, take this. Now flip that over and let's look at the other side of the coin. Bases are defined as substances that accept those H+ ions in solution, or they produce OH- ions. So if acids are the frantic donors giving things away, bases are the ultimate acceptors in this molecular game. They are more than happy to just take in those positively charged hydrogen ions, or they'll release negatively charged hydroxide ions just to perfectly balance the whole thing out.
Section 2, A Tale of Opposites. Let's actually compare their personalities, starting with how we experience them in real life and where they sit on the chemical scale. Acids, they have a famously sour taste. That's the lemon we were talking about earlier. They also live way down on the lower end of the pH scale, specifically coming in with a pH of less than 7. Bases, on the flip side, are characteristically bitter to the taste, and they completely dominate the upper half of the scale with a pH greater than 7.
And you know, these differences really build directly into their physical traits too. Acids are highly reactive. In fact, they're so reactive that when they come into contact with metals, they actively liberate H2 gas. It is a very dynamic, bubbly process. Bases show their physical presence a bit differently. They are famously slippery to the touch. Seriously, that is exactly why soap, which is a classic base, glides so smoothly through your hands. But here's the wild part. Despite this intense chemical rivalry, they actually share one absolutely crucial common ground. Whether you're dealing with a sour, metal-reacting acid or a bitter, slippery base, they both do one thing remarkably well. When they're in an aqueous solution, which is just a fancy way of saying dissolved in water, both of them conduct electricity. It's such a fascinating shared trait between completely opposite substances. All right, let's put some actual names to these traits. We've got some famous acid contenders to look at. On one hand, you have your major industrial heavy hitters, right? Things like hydrochloric acid, or HCl, and sulfuric acid, H2SO4. But then you also have everyday heroes on this list. Acetic acid is the main component of the vinegar sitting in your pantry, and citric acid is what gives you that classic citrus pucker.
And facing off against them is the opposing team of bases. You're definitely going to recognize some of these from household cleaners or maybe high school chemistry class. We've got sodium hydroxide, or NaOH, there's potassium hydroxide, KOH, and calcium hydroxide, CaOH2. Oh, and we definitely can't forget ammonia, NH3, which is basically a staple in cleaning products worldwide.
Section 3, The Color-Changing Clues.
So, because acids and bases are very often just clear, boring-looking liquids, chemists have to use this brilliant sort of decoder ring to reveal their true identities. We call them chemical indicators. These are substances that change color entirely, literally, depending on whose team they're playing for. Take phenolphthalein, for example. It stays totally colorless in an acid, but man, it bursts into a vibrant pink in a base. Or methyl orange. It shifts from red in acid to yellow in a base. It feels like magic, but it's just pure awesome chemistry.
Of course, we have to talk about the most famous indicator of them all, the litmus test. This is like the ultimate chemical flip-flop. If you've got an acid, it's going to take blue litmus paper and turn it red. But if you have a base, it does the exact opposite, taking red litmus paper and flipping it blue. So, red for acid, blue for base, always keeping to their separate sides.
But hey, you really don't need a fancy laboratory to witness this stuff. The source material points out something totally amazing about turmeric. Yeah, the common spice that's probably sitting in your kitchen cabinet right now. Turmeric is actually a natural indicator. If it meets an acid, nothing happens. Absolutely no change. But the second it encounters a base, it dramatically shifts to this deep reddish-brown color. How cool is that? Section 4. The ultimate chemical clash.
So what actually happens when the sour, metal-reacting acid meets the bitter, slippery base head-on? Well, the answer is neutralization, and it's an incredible chemical phenomenon. You see, when an acid reacts with a base, they don't just explode or destroy each other in some chaotic mess. Actually, scratch that, it's the total opposite. They perfectly neutralize each other's extremes. The acid's H+ ions and the base's OH- ions lock together, completely canceling out their intense, dangerous properties to form something entirely peaceful: salt and water.
Let's walk through the exact chemistry of how this clash goes down. In step 1, the reactants. We bring in a really powerful acid, hydrochloric acid, or HCl, and a powerful base, sodium hydroxide, NaOH. When they finally battle it out, the chemical bonds shift, the dangerous extremes just vanish, and we are left with the products in step 2. NaCl, which is literally just ordinary table salt, and H2O, pure water. The clash ends in perfect harmony.
It really is amazing when you stop and think about it. If two incredibly powerful opposites, things capable of dissolving metal or burning skin, can just combine to create nothing more than harmless table salt and a glass of water, it makes you wonder, what other delicate chemical balances are silently working behind the scenes, holding our entire world together? Definitely keep that in mind the next time you wash your hands or squeeze a lemon. Thank you so much for joining me for this explainer, and as always, stay curious.